Moving on from the previous module, let's add a new BPSC caller to another actor and set it up. We'll make this standing light interactable. Select Point Light 6. Click Add Component and add a BPSC caller. Notice the two defaults for the enums. eAction is defaulting to Call Interface. This means that it's not going to do anything except call the interface to let everyone who is listening know that it has just been called. eActivation is defaulting to Press. This means that it is waiting for the call from the player directly pressing it. Pressing is done inside of the first-person character. Open that blueprint that was provided with the first-person template located in the content browser inside of ArcViz Interior First-Person BP Blueprints, and open first-person character. Let's see what has been changed. Pan down to the Input Action Fire event. Towards the end of this event, there is a line traced by channel node. We've replaced the impact mechanic from the original blueprint, and from the out-hit result, we are checking if we hit something, and if so, check if the actor that was hit contains the BPSC caller component, and if it does, call the event user_pressed that is located in the spawned controller variable. Click on the little magnifying glass on the Get Component by Class node. This will take us to the location inside of the content browser that BPSC caller is located in, and open it up. At Event Begin Play, a new actor is spawned at the world transform of the pivot we placed BPC caller. The spawned actor is BP controller, and after it is spawned, it is cached in the variable spawned controller. After spawning BP controller, we are transferring all the values contained in BPSC caller to the same variables inside of BP controller. After we transfer all this data, BP controller is now in charge. Let's quickly go through a couple of key points. First, in the map, select the door handle. Inside of the world outliner, the door handle is a child of door trim inner. Door trim inner is a child of door. If we wanted to rotate the door handle, that's one thing, but we also want to rotate the door. And as we have seen, the pivot points are not in the correct locations to rotate properly. Select door trim inner and notice that the pivot is in the middle of the door. If we were to try and rotate from here, the door of course will rotate from the center. Select the BPSC caller component, and now we can see that the pivot is at the bottom right. We need to think about how to programmatically reparent these meshes while keeping the hierarchy intact. Open BP controller and pan to Event Begin Play. We are going to need to reparent door trim inner to this BP controller, which remember spawns at the identical transform as BPSC caller. If we reparent this door trim inner though, we are removing it from its old parent, which was the static mesh actor door. Now it has been removed from its old hierarchy, and all children of door trim inner are now on their own. This would result in the door opening correctly, but the door handle staying put. To maintain this hierarchy, we are telling BP controller to attach to the original parent, which is what we attached BPSC caller to by adding it as a component. We get that information from the Get Attach Parent Actor node. Then attach the original parent, again what we added BPSC caller to this blueprint BP controller. Let's look at this visually. Open the map again and look at the hierarchy of the door. Now press Alt-S to simulate the scene. See how hierarchy is maintained. Select the BP controller above door trim inner and notice that we can now rotate it properly. We will now be able to successfully play an animation of the door handle turning while the door itself opens, and the handle will stay attached and follow as expected. Back inside of BP controller, pan down to Event User Initiated Action. This is the event that we're using from our blueprint interface. It first checks the value of eActivation. If it is set to wait for other actor, and the actor to wait for is equal to what is returned in the event, it will proceed. If either of these are false, it will ignore the call. If it does proceed, it will call a function named determineAction. Double-click this event call. After it is called, it then calls another function named callInterfaceToInitiateAction, which will then tell the Blueprint interface to update any actor listening that this actor has just been called. Next, a switch node to decide which route to take. Let's focus on the change color route for the light we are working on. The function cycleLinearColor is called, and there is a bool input named manualSelection. It is false right now. Let's open this function to see what that means. If manualSelection is false, it means that the function should be automatically cycling through available colors on its own. From false, there is another branch that is asking if the value of eColor converted to an integer is greater than or equal to the number of enumerators inside of eColor. Because we are cycling through this enumeration, we will eventually reach the end of it. That's what this is asking. Have we reached the end of possible enumerators? If so, set it back to 0, and if not, add 1 and set. Panning over shows a return node that contains a new color variable of type linear color. From new color, we are deciding what the value is from each of the enumerators. So eColor, as we can see, is filled with a row named original, and then a row for each color in roygbiv. We can of course change the color inside of each value, as the enum contains only the readable word. Just because it says green, for example, doesn't mean that we must keep it green. That is just for us. The program is not seeing the words red or blue or whatever. It is identifying each row by a byte. This is how we are able to automatically cycle the enum by converting this byte into an integer that we can compare. Using a select node like this allows for as many possibilities as we want, as we can add another select node onto the current one as many times as makes logical sense. If manual selection were set to true, we can set the color of eColor based on the value it was before we called this function. So here we are saying that if it was original, we want it to now be indigo. If it was indigo, now be red, and so on. Then, based on this value, it will again set the new color the same way. Back in the details panel of Point Light 6, select BPSC Color. Let's set eAction to change color and eActivation to wait for other actor. Because the light has no physical form, we need to rely on something else to communicate with it, such as another mesh or a hood. Select the dropper next to Actor to wait for and select the standing lamp. We need to also add a BPSC caller to the lamp. Select the lamp and add it the same way we've been doing. Because the default of eAction is already call interface and the default of eActivation is press, we don't need to do anything further. Press play and walk over to the lamp and press it. We could see that the lamp light is changing colors. So what is happening here is the first-person character that we are possessing is detecting the standing lamp and checking if it has a component of type BPSC caller, and if so, tell the BP controller that it has spawned to call a function inside of our Blueprint interface and ask if any other actor was listening for this update from this actor, and if so, determine what action to take. This results in this light changing color automatically by cycling through an enumeration named eColor. We need to talk about how it knows it's a light and not a parameter in a material. Remember, I can turn around and press the wall and it too will change colors. Let's stop playing and open BP controller. After the cycleLinearColor function is called, we are casting to light. Light is an object type that the point light inherits from. So by casting to light, we are asking if this actor inherits from light, and if so, call the available function setLightColor located inside of lightComponent. If the cast has failed, meaning this actor is not inheriting from light, we will assume it is a static mesh and call the function setVectorParameterValue That is available because we created a dynamic material on begin play in the function getOriginalColor. If this is not a light, we will cast to static mesh actor, and if it is a static mesh actor, create the dynamic material instance and get the original color from that vector. To learn more about material parameters, which are needed to accomplish this change, there are other great courses on our Unreal Online Learning platform that discusses this in detail. Alright, so in this course, we learned what an enumeration asset is, how to make one, and learned a few examples of how to use one inside of blueprints and UMG to alter behavior from specific interactions. We then used a real-world example of adding reusable interactions to a scene and learned new techniques for building our blueprints and communicating between them. As I previously mentioned, early planning of the types of mechanics that your scene will need and how best to prepare for them will save a lot of time and allow for quicker revisions. All the interactions we've gone through here are in one blueprint, so any change to this one will be propagated to them all. There are many more techniques and logic flow that I've left detailed comments to inside of BP Controller. Feel free to break them down for your own projects. I hope you learned some new techniques, tools, and nodes that you can comfortably use. Thanks for watching, and good luck out there.